Alright, so there are different types of chemical reactions. So the first one is the combination reaction that has a general equation of A plus B yields AB. That means in combination reaction, you are just combining reactants in order to form a product. So the reactants are A and B, and if we combine these two, AB will be our product or the new substance. Let's have an example. Sample, we have Na and Cl. Na is sodium and Cl is chlorine. We're going to combine these two reactants, will end up with NaCl. But before you predict the product, you have to check the oxidation number. For sodium, we have +1, and for chlorine, we have -1. So basically, we can cancel out, and then you will have NaCl as the product of sodium and chlorine. And this is an example of combination reaction. Alright, so the second one is the composition reaction that has a general equation of AB yields A plus B. In the composition reaction, this is the reverse of combination reaction. It involves the breaking down of a substance into two simple substances. So as I've said a while ago, the general equation is AB yields A plus B. So let's have an example. Sample, the reactant is water that has a chemical formula of H2O. When it undergoes the composition reaction, it's going to break down into hydrogen and oxygen. Alright, the third one is the single replacement reaction. Sometimes they are called substitution reaction. In this reaction, an uncombined element replaces another element in a given compound. So our general equation for single replacement reaction is A plus BC yields AC plus B, wherein A plus BC are the reactants and AC plus B are the product. So let us have an example of single replacement reaction. So we have copper, Cu, and silver nitrate as our given reactants. And then following the general equation of single replacement reaction, we'll try to find out the product. If copper has high activity series than silver, therefore copper can replace the position of silver. So the product will be copper nitrate and then silver. You have to refer to the activity series in order to predict the product in single replacement reaction. Alright, so the fourth one is the double replacement reaction. So this type of reaction involves an exchange of ions between two reactants. So our general equation for double replacement reaction is AB plus CD yields AD plus CB. Okay, so let's have an example of double replacement reaction. Example, we have NaCl or sodium chloride plus K2SO4 or potassium sulfate as the given reactants. Now, since this is the exchange of ions between two reactants, let's see what will be the product between sodium chloride and potassium sulfate. So you need to apply here the crisscross method in order to predict the correct formula. So in this case, sodium has an oxidation number of +1, and then sulfate has an oxidation number of -2. So if we're gonna apply the crisscross method, this -2 will go here, so that's why we have 2 here, and then this one will go here. So since it is 1, it's okay not to write it, alright? So it's okay to have Na2SO4 as your final formula for the combination and exchange of ions between sodium and sulfate. And then the other product is K and Cl. So K has an oxidation number of +1 and Cl has an oxidation number of -1. So we'll just simply cancel out these two and you have KCl. So our chemical equation now for double replacement reaction is NaCl plus K2SO4 yields Na2SO4 plus KCl, or sodium chloride plus potassium sulfate yields sodium sulfate plus potassium chloride.